Dear students, welcome. Today I am going to start statics. What is statics? I am going to start statics. Statics is that branch of mechanics which deals with the action of forces, on bodies thus kept at rest and investigates the conditions which such forces satisfy. Statics is that branch of mechanics which deals with the action of forces on bodies thus kept at rest and investigates the conditions which such forces satisfy. Let us, without wasting more time, let us give some definitions. Number one, I am going to define you the resultant of two or more forces. Resultant of two or more forces. If two or more forces acting on a body, acting on a particle, on a point or a particle, if two or more forces acting at a point, you may write at a point or at a particle, acting at a point, can be replaced by a single force without affecting the body. The effect on the body or particle remaining unchanged or unordered, remaining unchanged. Then the single force is called the resultant of the forces. Two or more forces, I have written here two or more forces, is called the resultant of the forces. If two forces can be replaced by a single force, the effect on the body remaining unaltered, then this single force is called the resultant of the two forces. This single force is called the resultant of the forces. And in turn, the forces are called the components of the single force. Suppose P and Q are two forces. The combined effect of P and Q be R. Means P and Q, the two forces P and Q can be replaced by another force R. Then R is called the resultant of the forces P and Q. Resultant of the forces P and Q. And the forces P and Q are called the components of the force R. R is called the resultant of P and Q, and P is called the component of R. Q is also called the component of R. Now, now law of parallelogram of forces. let me define law of parallelogram of forces. Let me define law of parallelogram of forces. If two forces acting at a point be represented in magnitude and direction by two adjacent sides of a parallelogram, then the diagonal through that point which the adjacent sides meet, the diagonal will represent the resultant of the two forces. This is called the law of parallelogram of forces. Let me write this. If two forces acting at a point be represented in magnitude and directions, by two adjacent sides of a parallelogram, then adjacent sides of a parallelogram, then the diagonal, then their resultant will be represented in magnitude and direction. Then the resultant will be represented in magnitude and direction by the diagonal. Of the parallelogram, through which the adjacent sides of the parallelogram meet. By the diagonal of the parallelogram through the point, you may write through the point, which the adjacent sides of the parallelogram meet. What we have written here, you see, if two forces acting at a point be represented in magnitude and direction by two adjacent sides of a parallelogram, then their resultant will be represented in magnitude and direction by the diagonal of the parallelogram. What is that? There will be two diagonals. That diagonal will be taken through which the adjacent sides meet. There will be two diagonals. That diagonal will be taken by the diagonal of the parallelogram through the point which the adjacent sides of the parallelogram meet. Now, let us suppose that OABC be a parallelogram. Let us suppose that OABC be a parallelogram, and P force and Q force be represented by the adjacent sides OA and OC of the parallelogram OABC. Then their resultant, suppose their resultant be R. will be represented in magnitude and direction by the diagonal OB, by the law of parallelogram process. By the law of parallelogram process. Suppose that the forces P and Q be represented in magnitude and direction. Suppose that the forces P and Q be represented in magnitude by the two adjacent sides. By the two adjacent sides, OA and OB, not OB, OA and OC of the parallelogram. OABC. What is this? OABC is a parallelogram. Suppose the force P is represented by the side OA and the force Q be represented by the side OC of the parallelogram OABC. This means we have OA, this is equal to P vector and vector. Force A is a vector quantity. Therefore, OC, you should write the vector sign here. OA vector is equal to P vector, OC vector is equal to Q vector. Let the resultant of P and Q be R. Let the resultant of P and Q be R. Let the resultant of P and Q be R. Resultant of P and Q be R. By the law of parallelogram process, law of parallelogram process, the resultant R will be represented by OB. The resultant R bar of P and Q, of the process P and Q, will be represented by the diagonal OB of the parallelogram OABC. By the law of parallelogram process, the resultant R bar of P and Q will be represented by the diagonal OB of the parallelogram OABC. Therefore, OB vector will be represented by R vector. Now, OC and AB are parallel. Now, OC equal to AB, since it is a parallelogram, and OC is parallel to AB. Therefore, AB vector equal to OC vector. This is equal to OC vector is equal to Q vector. Therefore, this AB vector also can be represented by Q vector. AC vector will be represented by Q vector. Right? Now, from the triangle OAB, OA vector plus AB vector, this is equal to OB vector. This means P plus Q vector equal to R vector. P plus Q vector equal to R vector. P plus Q vector equal to R vector. If by the law of parallelogram of forces, if two forces P and Q be represented in magnitude and direction by the two adjacent sides of a parallelogram, then their diagonal through their meeting point will represent in magnitude and direction the resultant of the forces P and Q. And from vector we have calculated that, we have established that R vector equal to P plus Q. If R is the resultant of P and Q, P vector and Q vector, P force and Q force, then R vector equal to P vector plus Q vector. I have been talking about vector. Force is a vector quantity, therefore you must write here vector sense. You must write here vector sense. And we shall establish all the theorems in vector method. P R vector is equal to P. Resultant vector equal to P vector plus Q vector. R equal to P plus Q. Now suppose that the angle between P and Q is alpha. Suppose that angle between P and Q is alpha. Not only that, R vector makes an angle theta with the direction of P vector. And without writing this parallelogram also, you may write here, this is alpha, this angle is alpha, the whole angle is alpha, and this is angle theta. This is angle theta. Now see, let alpha be the angle between the line, between the forces P and Q. You may write between the forces P and Q. Also, the resultant R vector R makes an angle theta with the force P, and the resultant R vector makes an angle theta with the force P, vector. Right? Now see. Perhaps you are enjoying this. R vector makes an angle theta with P. Angle between P and Q is alpha, angle between R and P is theta. Now, R vector equal to P plus Q. This means R vector dot R vector equal to P plus Q dot P plus Q. P plus Q dot P plus Q. This means the magnitude of the vector R into cos. The angle between two same vector is 0, cos 0 equal to P vector dot P vector, P vector dot Q vector, Q vector dot P vector plus Q vector dot. I am talking about vector means P force dot P force dot Q force. You may write like this also. This means R, this is 1. The magnitude of the resultant R is equal to R. This is equal to, here also, cos 0 plus 2 times of P vector dot Q vector. Since the dot product is commutative, and in similar way, you may write like this. Since the dot product is commutative, since P vector dot Q vector equal to Q vector dot P vector, dot product is commutative, therefore you may write like this. Also, R vector modulus equal to R. the magnitude of the vector, magnitude of the resultant is R. This means R square equal to PP, cos 0 means 1, plus 2 times of P, Q. What is the angle between P and Q? Alpha, cos alpha, plus Q, and 1. This means R square is equal to P square plus twice PQ cos alpha plus Q square. Cos alpha plus Q square. This means R square equal to P square plus Q square plus twice PQ cos alpha. Mind that the P vector equal to P. This means we have written this. The magnitude of the force P is P and the magnitude of Q is Q. Magnitude of R is R. This means R equal to root of R P square plus Q square plus twice PQ cos alpha. This gives the magnitude of the resultant of P and Q. If two forces P and Q meet at a point and the angle between the lines of action of P and Q is suppose alpha, then their resultant will be equal to root of R P square plus Q square plus twice PQ cos alpha. You should remember this. Which gives the resultant of P and Q? Which gives the magnitude of the resultant of P? Which gives the magnitude of the resultant of P and Q. Of the forces of P and Q means of the forces P and Q. Of the forces P and Q. Now, of the forces P and Q. Remember it. You will have to remember this. The magnitude of two forces P and Q acting at a point, at an angle alpha, is equal to root of R P square plus Q square plus twice PQ cos alpha. Remember this. Now, R vector equal to P plus Q. R vector, this is equal to P plus Q. P dot R will be equal to P vector dot P plus Q. You will get this one. This means PR cos theta. It will be cos theta. The angle between P and R is theta. Therefore, magnitude of P means P, magnitude of R is R. This is cos theta equal to P vector dot P vector plus P vector dot Q vector. You will get this one. You will get this. This means PR cos theta equal to, it will be P square. P vector dot P vector is equal to P square plus P into Q cos, the angle between P and Q is alpha. P Q cos alpha. This means R cos theta equal to P plus Q cos alpha. Suppose this is number 1. Suppose this is number 1. This is number 1. We have taken dot product with P vector, P force. Then we have established this relation R cos theta equal to P plus Q cos alpha. Now P, take the cross product with P, then you will get P vector cross P plus Q. This means P cross R vector equal to P. You will get this one. Certainly you will get this. This means P cross R equal to P cross Q, since P cross P vector equal to 0. Therefore, the angle, since the angle between P and P is 0, therefore sin 0 equal to 0. It will be obviously 0. This means two vectors are same, therefore their magnitudes are also equal. Two vectors are equal means magnitudes are also equal. Magnitudes are also equal. This means P R sine, the angle between P and R is theta, sine theta, equal to P Q sine, angle between P and Q is alpha. Sine. This means PP will be cancelled, R sine theta equal to Q sine alpha. Suppose this is number 2. This is number 2. 2 divided by 1. Dividing 2 by 1, we will get R sine theta by R cos theta. This is equal to Q sine alpha divided by P plus Q cos alpha. We will get this one. P plus Q cos alpha. This means tan theta equal to Q sine alpha divided by P plus Q cos alpha. You should also remember this. Suppose this is number 3. Remember this. This gives the direction of the resultant of P and Q, which gives the direction. 3 gives the direction of the resultant of P and Q, which gives the direction of the resultant of the forces P and Q. Resultant of the forces P and Q. Now, from 2 you may write, from 2 or from 2 you may write Q equal to R sin theta by sin alpha. This is number 4. Q equal to R sin theta divided by sin alpha. You may write like this. From 1, P plus Q cos alpha, P plus Q cos alpha, this is equal to and you may write from 3, from 1 also equal to, but from 3 I am going to express P in terms of R. P plus Q cos alpha equal to Q sin alpha by tan theta. Sin alpha by tan theta. Sin alpha by tan theta. You may write sin alpha divided by tan theta. Or P equal to Q sin alpha by tan theta. Tan theta means sin theta by cos theta. Minus, take it to the right and say cos alpha, you may write here cos alpha. Or P equal to Q sin alpha cos theta divided by sin theta. Minus cos alpha. Cos alpha. Now, from 4, replace Q by R. Replace Q by R sin theta by sin alpha. Sin alpha cos theta by sin theta. Minus cos alpha. Using 4. Just use 4. Using 4, you may write like this. This means P equal to R by sin alpha multiplied by sin theta, sin alpha cos theta minus cos alpha into sin theta. Or P equal to R sin alpha minus theta divided by sin alpha. Sin alpha. This is number, suppose 5. We have expressed P and Q in terms of R, alpha and theta. Now, one thing I am going to tell you. It was force P, it is suppose Q, the resultant is R, the angle between the two forces is alpha, the angle made by the resultant R with the force P is theta. Suppose this angle is phi. Suppose this angle is phi. Let us suppose that let R vector makes an angle phi with the direction of the force Q. With the force Q, you may write with the force Q also. Direction of the force Q. With the direction of the force Q. Then theta plus phi equal to alpha. You will get theta plus phi equal to alpha. Theta phi plus phi is equal to alpha. Therefore, 4 implies. From 4 you will get Q equal to R right here sin theta divided by sin theta plus phi sin theta plus phi. From phi P equal to R sin theta plus phi, right? Theta plus phi for alpha divided by sin alpha. Alpha means theta plus phi. Or you can write P equal to R sin phi divided by sin theta plus phi. You may write in this way. Means if P and Q are two forces acting at a point, angle between P and Q is alpha. The resultant of P and Q makes an angle theta with the force P, and resultant of P and Q makes an angle phi with the force Q. Then we can express P. What is P? In terms of R equal to R sin of phi, R sin phi divided by sin theta plus phi. What is theta plus phi? The angle between P and Q. Also Q equal to R sin of angle this, sin of angle theta, sin of angle theta divided by sin theta plus phi. We can express like this also. Now, what we have learned so far? Law of parallelogram of forces we have defined, and using the law of parallelogram of forces we have derived that the magnitude of the resultant of P and Q is given by root of R, P square plus Q square plus twice PQ cos alpha. What is alpha? Alpha is the angle between the two forces P and Q. Number 1. Number 2. If the resultant makes an angle theta with the force P, then tan theta is equal to Q sin alpha divided by P plus Q cos alpha. Q sin alpha divided by P plus Q cos alpha. Suppose if the resultant are makes an angle, suppose phi with Q, then also you can write tan theta, tan phi equal to Q. It will not be Q. P sin phi, Q sin alpha. Alpha is the angle between P and Q divided by, in place of P plus Q, sin alpha, you will have to write q plus p sin alpha. Q plus p sin q plus p cos alpha in the denominator. What I am going to tell you, if this one, tan theta is equal to this. When what is theta? Theta is the angle between the resultant R with the force P. If theta is the angle between the resultant R with the force Q, then you will get tan theta is equal to P sin alpha divided by, for P plus Q cos alpha you will have to write Q plus P cos alpha. This one is this. If the resultant makes an angle Q, if the resultant makes an angle P, then tan theta will be equal to Q sin alpha divided by P plus Q cos alpha. If the resultant makes an angle theta with the force Q, then tan theta will be equal to, replace interchange the positions of P and Q. For Q, you will have to write P. For P, you will have to write Q. For this Q, you will have to write P. That's all. Now, the resultant of, now I am going to derive some corollaries. Now, corollaries. Corollaries, and these two, suppose this is number 5 and this is number 6. 5 and 6 will be 5 and 6. I am going to tell you something about 5 and 6. Now, corollaries. Some corollaries. Some corollaries. Number 1. If the angle between the forces P and Q be 90 degree, if the angle between the forces P and Q be 90 degree, then R equal to root over P square plus Q square plus twice PQ cos in, that is alpha is equal to 90 degree, cos 90 degree is equal to 0. This means you will get this one. R is equal to root over P square plus Q square. The resultant will be equal to root over P square plus Q square, when the angle between the two forces P and Q is 90 degree. Corollary number 2. Corollary number 2. Also, you may write one thing also. Tan theta equal to Q sin 90 degree divided by P plus Q cos 90 degree. Or you may write tan theta is equal to Q divided by P, Q into 0. This is 1. This means tan theta is equal to Q by P. This is also a relation. Or theta is equal to tan inverse Q by P. When the angle between the two forces P and Q is 90 degree, then we will get this result also. Now, corollary number 2. This result, I will compare this with some more results. Therefore, I am not removing this one. P equal to R sin phi divided by sin theta plus phi. This one. Corollary number 2. The greatest value of cos alpha equal to 1. The greatest value of cos alpha. cos alpha equal to 1. Therefore, the greatest resultant will be equal to. Therefore, the greatest resultant magnitude of resultant will be given by r equal to root of p square plus q square plus twice pq cos alpha means 1. This is equal to 1. This is equal to root of r p plus q whole square. This means r equal to p plus q. The greatest magnitude of the greatest resultant will be equal to p plus q. This is the greatest resultant. Greatest magnitude of the resultant of p plus q. P and q. This is equal to greatest magnitude of resultant. Magnitude of resultant of p and q. But cos alpha equal to 1 means cos alpha equal to 1 gives us alpha equal to 0 or 0 equal to 1, alpha is equal to 0. This means if the angle between p and q is 0, then we get the greatest resultant. Then we will get the greatest magnitude of resultant. Gives us alpha is equal to 0. Means angle between the two forces is 0. Then we will get the greatest magnitude of the resultant of the forces P and Q. Number 3. The least value of cos alpha equal to minus 1. Therefore, the least magnitude of resultant. Therefore, the least magnitude of the resultant of P and Q will be R equal to root of R p square plus q square plus twice pq cos alpha means minus 1. This means p minus q whole square. This means R is equal to p minus q. This is equal to least magnitude of resultant. What is this? Least magnitude of resultant. Least magnitude of the resultant. Right? But cos alpha equal to minus 1 means, but cos alpha is equal to minus 1 gives us alpha is equal to 180 degree. Alpha is equal to 180 degree. Means when the forces are in opposite directions, we get the least magnitude of resultant. That is when the lines of action of the forces P and Q are in opposite directions. That is when the forces P and Q acts in opposite directions, then we get the least magnitude of resultant of P and Q. That is when the forces P and Q act in opposite directions, then act in opposite directions, then we get the least, then we get the least magnitude of the resultant of P and Q. Right? What we have got this so far, if the angle between P and Q is 90 degree, then the magnitude of the resultant is root over p square plus q square. That's all. The greatest magnitude of the resultant of p and q is p plus q. Least magnitude of resultant of p and q is p minus q. And at that time, for greatest force alpha equal to 0, for the least force alpha is equal to 180 degree. This alpha is equal to 180 degree means what is alpha? Alpha is the angle between the two forces p and q. This means p and q acts in opposite directions. When p and q acts in opposite directions, then we get the least magnitude of the resultant of p and q. When p equal to q, suppose corollary number 4. When p equal to q, then r square equal to p square plus for q square you will have to write p square twice p into cos alpha. This means r square is equal to twice p square plus twice p square cos alpha. This means r square is equal to twice p square into 1 plus cos alpha. This means r square is equal to twice p square twice cos square alpha by 2 twice p square cos square alpha by 2. You may write like this also. Four p square r square is equal to 4p square alpha by 2. Or you may write r is equal to twice p cos alpha by 2. If p is equal to q, then we will get this one. Also, at that time tan theta is equal to q p sin alpha divided by p plus p cos alpha. You get this one also. Tan theta is equal to p sin alpha divided by p. Right? Q is equal to p in both the cases. This is equal to pp will be cancelled. Sin alpha divided by 1 plus cos alpha. Sin alpha divided by 1 plus cos alpha. This is equal to twice sin alpha by 2 into cos alpha by 2. This will be equal to twice cos square alpha by 2. This is equal to 2 will be cancelled. This will be equal to tan alpha by 2. This means theta is equal to alpha by 2. Theta is equal to alpha by 2. What does it mean? Theta is equal to alpha by 2. When the forces are equal, then the resultant bisects the angle between the two forces P and Q. This means that, what does it mean? This means that when the forces are equal, this means that when the forces are equal, this means that when the forces are equal, then the resultant bisects or divides the angle in two parts, in two equal parts. The resultant are equal, then the resultant of two forces P and Q, P and Q are equal, then resultant of the forces bisects the angle between the two forces. When the forces are equal, P and P, the resultant will make equal angles with both the two forces. This means that the resultant bisects the angle between the two forces. Resultant bisects the angle. Generally, the resultant also the resultant of the two forces will be nearer to the greatest force. You should also remember this. You may also remember this. The resultant of two forces will be nearer to the greater force. You may write number 5, the line of action or the direction of the line of action of the this resultant will be nearer to the greatest force of the resultant of two unequal forces will be nearer to the greater force. Will be nearer to the greater force. Resultant is nearer to the greater force. I listen. Oh. I have removed this one, but perhaps you have written this. The resultant will be nearer to the greater force if the forces are unequal. If the two forces are equal, resultant will make equal angles with both the two forces. But one force is greater, one force is smaller. Then resultant will be nearer to the greater force. I have just told you this one. Perhaps you have all noted down. Noted everything. So far, the resultant of two forces we have discussed. Now, I have already told you that R is the resultant of P and Q. P is also called the component of R. Q is also the component of R. P and Q are components of R. We are going to find the components in terms of the resultant. Now, P and Q, the forces. P and Q are the resultant of the forces. P and Q are the components of the force R. Are the components of the force R. R vector equal to R vector equal to P plus Q. R vector equal to P plus Q are the components of P. Now, let us suppose that the resultant R makes an angle alpha with the force P and beta with the force Q. Suppose these are component forces. P and Q are components of R, of the resultant R. And this angle is alpha, and this angle is beta. This angle is beta. This angle is alpha, this angle is beta. Now, Q cross R. Now, Q vector cross R vector equal to Q vector cross, no, R cross Q. Now R vector cross Q vector equal to P plus Q cross Q vector. You may write like this. Or you can write R cross Q, this is equal to P cross Q plus Q vector cross Q vector. These are forces. This four R vector Q vector equal to P cross Q. Since the cross product of two equal vectors equal to zero vector. Cross product of two equal vectors is equal to zero vector. Therefore, the magnitude of this should be equal to the magnitude of this. Equal to the magnitude of this. This means it will be magnitude R Q sine R and Q, the angle between R and Q is beta, sine beta equal to PQ sine alpha plus beta. PQ sine alpha plus beta. Or QQ will be cancelled, R sine beta. R sine beta equal to P sine alpha plus beta. This means P equal to R sine beta divided by sine alpha plus beta. Compare this with the result this. Same thing. R sine beta divided by in the previous example we took the angle between R and P is theta and R and Q is phi. Therefore, replace phi by beta and theta by alpha. You will get this, the same result. Now, the force, take the cross product of the force P and R. Cross product of the force P and R. Cross product of the force P and R. Equal to P plus Q. Then P vector cross R vector equal to P cross P plus P vector cross Q vector. Right? Now the cross product of two same vector, equal vectors, is equal to zero vector. This means P vector cross P cross zero Q. Since P cross P equal to zero vector, cross vector. I have written here zero vector because the dot product of two vectors is a scalar quantity, but cross product of two vectors is a vector quantity. This means P cross R. Magnitude, their two vectors are equal. Cross product of two vectors is a vector quantity. Their two vectors are equal. Means their magnitudes should also be equal. This means P R sine, the angle between P and R is alpha, equal to P Q sine, angle between P and Q is alpha plus beta. Alpha plus beta. PP will be cancelled. This means Q equal to R sine alpha divided by sine alpha plus beta. Sine alpha divided by sine alpha plus beta. These are the components. In this way, the components can also be found. The components can also be found in this way. In terms of a force R is given, their components can be found in this way. And also notice that two forces acting at a point have a single resultant, but a single resultant can have an infinite number of components because you can draw an infinite number of parallelograms. taking the given force as a diagonal of a parallelogram, you can construct an infinite number of parallelograms. Therefore, notice that an infinite number of components can be found from if a force is given. For a given force, we can construct an infinite number of parallelogram taking the force as diagonal. Therefore, we can find an infinite number of components of a given force. This should be noted. Now, I am going to give you a definition which is called the resolved parts. What do you mean by the resolved parts of a force? A resolved part, a force, for a force we have we can find two components. If the components are at right angles, then these components are called the resolved parts. Resolved parts of a force. Let me. Resolved parts of a force. Resolved part of a force. Of a force. Resolved part of a force. A force, from a force we have we can find two components. The components, if the angle between the two components is 90 degree. The components of a force, along two mutually perpendicular directions, the components of a force along two mutually perpendicular directions are called the resolved parts of the force. Are called the resolved parts of the force. You see, let R bar be a given force. Let R vector be a given force. Let OX and OY be two mutually perpendicular directions. Be two mutually perpendicular directions. OX and OY be two mutually perpendicular directions. Suppose these are two mutually perpendicular directions. R is a given force. Let R force makes an angle theta with the direction of OX. Let the force R makes an angle theta with the direction of X, OX, with the direction of OX. You may write the vectors in or not also, it is not with the direction of OX. Then then direction of position. Let P vector and Q vector be the components of R of the force R in the directions of OX and OY respectively. Suppose P and Q in the direction of OX and OY respectively. Now, obviously, since P and Q are components of R, therefore P plus Q is equal to R. Obviously. R vector equal to P plus Q. Now, P vector dot R vector equal to P vector dot R vector equal to P vector dot P plus Q dot product, and PR into cos theta, we have written theta, cos theta equal to P vector dot P vector plus P vector dot Q vector, or PR cos theta equal to, this is P square plus P magnitude of Q cos of, it is 90 degree because in mutually perpendicular directions, 90 degree. This means PR cos theta is equal to P square, since cos 90 degree equal to 0. PP will be considered. This means P equal to R cos theta. P equal to R cos theta. P equal to R cos theta. We have found P equal to R cos theta. Now, Q cross R. Now, Q dot R. What will be equal to Q dot R? Equal to Q vector dot P plus Q. Or QR cos, it will be 90 degree minus theta. Whole angle is 90 degree. Therefore, this theta. What will be this? This will be equal to 90 degree minus theta. 90 degree minus theta equal to Q dot P plus Q dot Q. This means QR, it is sin theta equal to, it is QP cos, it is again 90 degree plus, it is Q square. 90 degree equal to Q. Resolved parts of the forces. It is 90 degree means it will be equal to 0. This means QR sin theta. This is equal to 0 plus Q square. Since cos 90 degree equal to 0. Cos 90 degree is equal to 0. Cos 90 degree equal to 0. Therefore, we have to take this one. This means R sin theta. Q is equal to R sin theta. This means Q equal to R sin theta. P equal to R cos theta, Q equal to R sin theta. These are the resolved parts. Does the resolved parts of a force along two mutually perpendicular directions are R cos theta and R sin theta, where R makes an angle theta with the direction of P. These are the resolved parts. It is very easy to find the resolved parts. A force R is given, we have to find the resolved parts of the force into mutually perpendicular directions. Obviously mutually perpendicular directions. In one direction, if it makes an angle theta, then the resolved parts will be equal to respectively R cos theta and R sin theta. R cos theta in that direction and R sin theta in a direction perpendicular to that direction. r cos theta and r sin theta. Now, in addition to this, you may write, I am writing here no. Let I cap, j cap be the unit vectors along the directions of ox and y respectively. Suppose I cap and j cap. Let I cap, j cap be the unit vectors. Let I cap and j cap be the unit vectors along the directions of ox and y respectively. Along the directions of ox and oy respectively. Let I cap, j cap be the unit vectors along the directions of ox and oy respectively. Now, r vector dot I cap equal to what? Magnitude of r, magnitude of I into cos of r vector, the angle between this is theta. This means r vector dot I vector equal to, this is r1 cos theta. This means r vector dot I cap equal to r cos theta. What is r cos theta? R cos theta is equal to P. R cos theta, this is equal to P. Thus, P equal to r vector dot I cap. You may write P equal to r vector dot I cap. R vector dot I cap. Now, r vector dot j cap. Again, r vector dot j cap equal to magnitude of r vector, magnitude of j into cos of angle between r and j is 90 degree minus theta. 90 degree minus theta. This is equal to r unit vector, magnitude of the unit vector this sin theta. This means, I am writing here, this means r vector dot j cap equal to r sin theta. This is equal to q. This is equal to r sin theta equal to q. Thus, q equal to r vector dot j cap. What we have established here? What we have established here? You see, to find the result parts of a force in any direction, in this direction, the result part is P. To find the result part in any direction, we have of a force, we have to find the dot product of the force and the unit vector along the directions. R vector dot I cap. We get the result part of the force R in this direction. Also, when we find the dot product along these directions, we have taken the dot product of r vector r and j, then it is equal to q. Means to find the result parts of a force in this direction, what we have done, we have simply taken the dot product of the force r and a unit vector along that directions. Very interesting this one. You see, thus to find the result parts, to find the result part of a force, of a given force in any direction, we have to take the dot product of the force. We have to take the dot product of the force and the unit vector along the directions. And the unit vector along that direction. To find the result parts of a force of a given force in any direction, find the dot product of the force and the unit vector along the directions. What a beautiful result this is, you see. Along any directions. Now, see, next article I am going to tell you. Let the resultant of the force R be P and Q. Let the resultant of the forces P and Q be R. Let the resultant of the forces P and Q be R. Now, the sum of the result parts now before this, let I cap be the unit vector along the direction of OH. Let I cap be the unit vector along the direction of OH. Now, sum of the result parts, of the forces P and Q along the direction OH is equal to the result part of the force P along the direction OX. You take the dot product of the force P and the unit vector along the direction plus again dot product of the force Q and the unit vector along the direction. This is equal to P plus Q dot I. Since dot product is distributive, we have written since dot product is distributive, therefore you will write since dot product is distributive. This is equal to R vector dot I cap. Since R is the resultant of P and Q. Since R vector is equal to P plus Q. Why P plus Q? R vector is the resultant of P plus Q. The resultant of P plus Q is R. Therefore, what is this? The result part of R in the direction of OX. This is equal to result part of R in the direction of OH. Result part of R in the direction of OH. What we have found from this? Sum of the result parts of two forces along any direction. This is equal to the result parts of their resultant. Therefore, sum of the result parts of two forces along any direction is equal to the result part of their resultant. Sum of the result parts of two forces along any direction. Sum of the result parts of two forces along any direction is equal to the result parts of their resultant. along any way is equal to result part of their resultant along the same direction. Resultant along the same direction. Same direction. Sum of the result parts of two forces along any direction is equal to the result part of their resultant along the same direction. You may extend this to any number of forces. Sum of any number of forces, sum of the result parts of any number of forces in any direction is equal to the sum is equal to the result parts of their resultant along the same direction. Along the same direction. Along the same direction. Right? Now, I am going to give you one more theory. What is this? The resultant of a number of a system of coplanar forces. Resultant of a system of coplanar forces. Resultant of a system of coplanar forces. Suppose you know OX, OY mutually perpendicular directions. OX, OY mutually perpendicular directions. Forces P1, forces P2 up to forces suppose Pm, which makes angle alpha 1, it is suppose alpha 2, and this angle is suppose alpha n, makes angles alpha 1, alpha 2 up to alpha n with the positive direction of x-axis OH. Suppose OR be the resultant, OR be the resultant, it makes an angle theta with the direction of x-axis. Suppose I cap and j cap unit vectors along the directions of OX and OY. OX and OY. Let P1, P2, P3 up to Pn be forces acting at the point O. Suppose that the forces P1, P2, P3 dot 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 up to Pn are acting at the point O, whose resultant is R. Therefore, you will get R vector is equal to, it is the resultant of this, you will get this one. Resultant, this is R vector, it is the resultant. This is resultant. This is resultant. R vector is equal to this. Let OX, OY be two mutually perpendicular directions. Let OX and OY be two mutually perpendicular directions. Let I cap, j cap be the unit vectors along OX and OY respectively. Let I cap and j cap be the unit vectors. Let I cap and j cap be the unit vectors along OX and OY respectively. OX and OY respectively. Suppose that the forces P1, P2 up to Pn make angles alpha 1, alpha 2, alpha n with the direction of with OX, you may write with OX, that's all, with OX. Make angles this with OX. Let the resultant are of what? P1, P2 up to Pn, P1, P2 up to Pn makes angle theta with the direction of OX. Means with OX, you may write with OX. Now, sum of the result parts of many forces, of some forces, of some of the result parts of a number of forces, of concurrent forces, along any direction is equal to the result parts of their resultant, equal to the result part of their resultant along the direction. Of the resultant along that direction. Sum of the result parts of a number of concurrent forces along any direction is equal to the result parts of the resultant along the same direction. Now, therefore, you will see result part of the resultant along the direction of OX, along the direction of OX equal to sum of the result parts of the forces along the directions on the item plus P3 item plus Pn right? Can I write like this? This means R cos theta equal to magnitude of R, magnitude of I, cos of angle, it is angle theta. R vector makes an angle theta with OX. R cos theta equal to P1 cos alpha, alpha 1, alpha 2, plus ... Pm cos alpha m, Pn cos alpha m equal to UC. Pn cos equal to UC. Suppose this is number 1. Suppose this is number 1. Now, also R vector dot j cap equal to P1 vector dot j cap, sum of the result powers, P2 dot j cap plus dot 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 plus Pm dot j cap. This means R sin theta will be equal to P1 sin alpha 1 plus P2 sin alpha 2 plus dot 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 Pm sin alpha n equal to V. See, suppose this is number 2. Suppose this is number 2. Squaring and adding 1 and 2 we get. Adding 1 and 2 we get R square cos square theta plus sin square theta. This is equal to U square plus V square. This means R is equal to root over U square plus V square, which gives the magnitude of the resultant. Which gives the magnitude of the resultant. Gives the magnitude of the resultant of P1, P2, P3 up to Pn. Dividing 2 by 1 we get. Dividing 2 by 1. Now dividing 2 by 1. I am writing here. Dividing 2 by 1. Dividing 2 by 1. 2 is R sin theta. And it will be R cos theta, which is equal to U by it will be P by U. P by U. This means tan theta is equal to V by U. This means theta is equal to tan inverse V divided by U, which gives the direction of the resultant which gives the direction of the resultant of the forces P1, P2, P3 up to Pn. This gives the directions, and that will give you the magnitude of the resultant of the forces P1, P2, P3 up to Pn, like this. We have given you the formulas which will be applied in the problem. In the next class, we shall solve some problems of this chapter. Today I want to stop here. Thanks for attending the class. Thank you very much. Thank you.